All right, so we've seen the form y equals x squared plus k, and we see k moves our parabola up and down here, right? So example 4, k moves our parabola up and down. So now we're going to get f of x is equal to negative x squared. F of x is equal to negative x squared. And with that, we're just going to plot points using integers between negative 3 and 3 and just seeing what this negative sign does to our graph here. So let's just start and say x, and our y values are equal to the function output, so y equals f of x. Negative 3, negative 2, negative 1, 0, 1, 2, 3. Put that all together. Well, what I'm going to get is negative 3 squared, right? So that negative is coming from there, and the number itself coming from the x squared is that piece right here. So whatever I square is actually just going to end up being negative. So this is just going to be negative 9. And that pattern continues. This will be negative 4. That'll be negative 1. This will be 0. Negative 1, negative 4, negative 9. Because that negative is outside the square, not inside the square. So what does that look like for us when we graph this? So let's put it together. Now let's make the x-axis a little bit taller. Let's not move that ruler too much. Perfect. So that's x, that's y. Turns out 0, 0 is still just there. That's okay. But now I have 1 and negative 1 instead of 1 and 1. And I have negative 1 over here. And we can already see that this is starting to take shape. And instead of going upwards, this is now going to point downwards, right? So I have going to point downwards now. So that negative base has reflected the parabola across the x-axis and going to come back around here, right? So it's reflected across the x-axis and going to come back around. Just like that. Perfect. All right, so that's our parabola. Looks great. Perfect parabola, just pointing upside down now instead of right side up. Vertex is still 0, 0. Domain hasn't changed, but the range now, when we consider the range here is now not y greater than 0, but this is y is less than that y. All our values of y are less than 0, right? 0 is now our maximum value, and we keep going down forever to negative infinity now, right? And now this opens downward instead of upward, right? It opens towards negative values, so we say this opens downwards. What we're going to look at now is we're going to try parabolas with this form where we have y equals ax squared plus k. And what we're going to find is that this a value, it can be 2, can be a half, it can be 3, could be 5, could be 6, could be 1 over 10, but it changes how fast our y values get to where we want to be. So we're going to find that this a value, if it's going to, first we check if it's positive or negative, so for opening up or down, but after that, if it's a fraction or a decimal, it's going to make our graphs wider, and if it's a whole number or a number greater than 1, it's going to make our graphs narrower because we're going to hit our y values faster. So what do I mean by that? Well, let's try the next example here. So with this is example 5. So example 5. And what happens here is this is y equals f of x is this function with a variable x equals 1/2 x squared by plotting the values between x, negative 4 and 4. So why that's chosen is because we'll get some nice even numbers out of that, right? So we want to get some nice even numbers to make things work. Let's start at a table of values, x and y equals f of x. And this will be negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. And this f of x here is 1/2 x squared, so this will be 1/2 negative 4 squared. Well, negative 4 squared is 16. 16 divided by half is 8. This will be 1/2 negative 3 squared. So that's 9/2. And that's equal to 4.5. So I'm just going to use the fractions, but you can find 0.5s, you can find the mix. Negative 2 squared is 4. 4 divided by 2 is 2. Negative 1 squared is 1. 1 divided by 2 is 1/2. 0 squared is 0. 0 times 1/2 is 0. And by symmetry, right, by the axis of symmetry here, we know that everything is going to be the same after our 0. So half 2, 4.9/2, and 8. If we had 25, we'd get 25/2, but if we had 36, we'd get 18, right? So we still were able to see that our pattern will continue, right? That the even numbers will have a whole number and the odd numbers will have a fraction. Let's see what this looks like. So let's make a nice graph here. Let's put it together. Looks good. We have a lot of room up there and there. So this is x, that's y, and all these are our point pairs. Let's start in the middle. So we're going to start at 0, 0 at our origin. Perfect. 1 and 1/2, we're just going to estimate 1/2 to be roughly halfway to our next grid line. It's not going to be exact, but it'll be close enough. 2 and 2 is right here. Normally, we'll show what it normally looks like without this change. This would be negative 2 and 2. Now this will be negative 3 and 4.5, which is going to be right there. And negative 3 and 4.5. Oh, that was positive 3 was the first one, and 4.5. This is negative 3 and 4.5. And the next one is 4 and 8. That's 5, 6, 7, 8. And that's 8 over here. And we're going to take this and we can see as we connect our dots here that this is now going to be a wider parabola, right? Our parabola widens out and we get a nice wider parabola. If we didn't have this wider parabola, right, what the original shape looked like, so I'll make this note here, y equals f of x equals 1/2 x squared. If we were to do the original parabola, y equals x squared, so I'm just going to use my squares. It'd be there, 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 2 and 4, negative 2, positive 4, and 3 and 9 would show up here. So my original parabola would look like this. And so what's happened is that I'm pulling the parabola arms down with that fraction, right? That I'm saying, okay, you're getting to your y values faster. What's being changed is this x squared. It's the y values that x squared has made our original y values, and now we're just saying, well, now our y values are half of what they used to be. So here, it used to be 9. Now that y value is half of 9. That's it right there, right? The y value used to be 4. Now it's half of 4. And here, the y value for this would have been 16. Now it's half of 16, 8. So that's the idea, is that it's saying it's half of the y values. Here it was 1, now it's half of 1. All right, so that's kind of what we're working with when we see this one. Let's try. I don't need to see a negative at the moment. The negative 2x squared example works the same way. What I'd like to do, let's check the time on this. And we got time for one more example. So the time for this one, this is example, I think that was example 5, so this will be example 6. And this example, what we're going to look at here, let's try graph y equals 1/4 x, actually this is f of x. Actually, let's do the one with the negative just to see that it gets skinnier. I'm going to do it a bit quicker. So let's do this. We'll do that example. Y equals f of x equals negative 2x squared. I'm going to do this a bit more quickly than the other example. So this is x and y equals f of x, right? So these are our two values that make a coordinate. Ooh, that was rough. These are two values that make a coordinate pair. And we'll just go from -3. Actually, we'll go to -2, -1, 0, 1, 2. We're going to see why we did that in a moment. -2 squared is 4. 4 times -2 is -8. -1 squared is 1. 1 times -2 is -2. 0 squared is 0 times -2 is 0. 1 squared is 1 times -2 is -2. And 2 squared is 4. 4 times -2 is -8. Now, if I did 3, I'd get 3 squared, which is 9. 9 times -2 is -18. So I'm not going to get a lot of, I'm not going to be able to fit those on the graph very well, right? So if I have a function that's, if I have a function that is increasing a lot like this, making it hit its y values faster, it's going to we'll be able to use less points for it, right? So here this would be 0, 0, -1, -2, and this will be 1, -1, -2. This will be 2 and -8, so that's 4, 5, 6, 7, 8 right there. And this will be it right there. Okay, and we're going to see that this is actually going to be a lot like skinnier than our regular parabola. That it's saying take the original parabola value and double it. Right? Take the original parabola value and double it. And what this has done is it also doubles our growth pattern. So instead of 1, 3, 5, 7, 9, that growth pattern, now it's going to grow by 2, 6, 10, and then 7, 14, right? So it's going to keep growing by times 2 of what the original growth pattern is. So this gets there faster. If we graphed -x squared, it would look like this. It would be over here. It'd be over here, and this would be -9 there. So you can see that if the blue was our original parabola, and the times 2 made us get to our y values 2 times faster, right? So it shrunk everything in, right? Or we would call that a compression. So this one is y equals -x squared, and then our red for comparison is y equals -2x squared. So we can see that we're just reaching our y values even faster. All right, last one, and then we move on to a somewhat separate topic. So example 7, and this one we have y equals f of x, and we have 1 over 4 x squared, and we'll do this from, we could even go bigger, -2. So we have 1 over 4 x squared minus 2, and it's like do this from x equals -6 to x equals 6. Let's give ourselves a wide graph to look at, because this is we're doing a lot of reduction here. Let's make our table of values. We have x, and we have y equals f of x. Putting it together, let's get these values here. So this is -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4. But I am going to do a trick with this. Maybe I won't have to calculate it all. For sure, if I do 0 squared, that's 0. 0 divided by 4 is just 0, -2, -2 here. So I know my vertex is just going to be 0, -2. So I at least have that worked out for me. But what I'm going to do now is I'm just going to pick even numbers. And I'm just going to pick the even numbers so I get nice integer answers. So negative 2 squared is 4. 4 divided by 4 is 1. 1 minus 2 is negative 1. Okay, that works nicely for me. Okay, let's go to negative 4 now. Negative 4 squared is 16. 16 divided by 4 is 4. 4 minus 2 is 2. And now 6 squared is 36. 36 divided by 4 is 9. 9 minus 2 is 7. By symmetry, I'm going to get the same thing happening here. So that's that's going to be negative 1. This will be positive 2, and that will be 7. And you can verify, you can take a moment to pause and verify that will all be there, right? So if you're not seeing the values, take a moment to verify just by plugging the value into f of x and seeing what you get. We could take the odd number values now. Negative 1 squared is 1. 1 divided by 4 is 1 over 4. If I did 1 over 4 minus 2, well, then I know on the number line, it's like saying this is also the same as saying negative 2 plus 1/4. So what this means is that I'm moving to the right on the number line. So I'm just going to do a side tangent here. So if I were at 2, 2, 3, 4, and this is negative 2, that's negative 1, 1, 2, 3, that's 0. Well, when I say add 1 over 4 here, then I'm just going to be at negative 1 3/4 now right there. So I'm at that point. So this is just going to be negative 1 and 3/4. So that means I'm moving closer here. And I can apply much the same logic to the rest of it with fractions as well. You can calculate it, use decimals, but we're going to get this level of comfort for fractions. This is where I'd like you to be. So negative 3 squared is 9. 9 divided by 4 is 9 over 4. Minus 8 over 4, that's 1 over 4. So that's that here. You can also do common denominator in your head as well too, right? So like you can do that mentally. Negative 5 is 25. 25 divided by 4 is 25 over 4 minus 8 over 4. This will be 17 over 4. As the number 17 over 4 is 4.25, right? If 4 fits into 16 4 times, and then it has a remainder of 1. So that'd be 4.25. And that looks nice there for us too. We can see the check that we should be having a number between 2 and 7 there. Okay, by symmetry, we'll get the rest of the values. So that's negative 1 and 3 over 4. The other one is going to be 1 over 4. And the last one is 17 over 4. So it's not too nice to actually do these fraction values. Best practice is you can kind of cheat it a little with even numbers to make it work out. If you have division by 3, you can cheat it with factors of 3 as well too. So let's go all the way over here, make that our y-axis. That's our y-axis. And we can leave us some room for the x-axis, like for above the x-axis. Most of the action is happening above the x-axis here. Go up, up, x, y. We're almost done this example. We're just going to get it onto a graph. This will be 0, negative 2. It's going to be difficult to graph the other things, so I'm just going to graph what I can. So I'm going to graph 2 and negative 1, graph negative 2, negative 1. Let's graph the 4 now. It's going to be 4 and 2, so that's this one here. That's 4 and 2, that's that one there. And I'm going to get negative 4, positive 2, and negative 6 and 7. So move over back, and then 1, 2, 3, 4, 5. Okay, negative 6 and 7. And positive 6 and 7 right up here. And this is still a parabola. We can like eyeball out the other things if we want. This was like 4.25. This was 1/4, so it was roughly here. And this was like 1/4 down here. Right? So that's where the in-between ones kind of were. Right there. And we can connect everything. The ones that are fractions are like our best guess at the moment. But as we do this, right, this stretches out further and further. as our bowl shape as we continue to increase this, right? Further and further, we get a nice big bowl shape there. Perfect. Okay, good. If we had, so this one here is y equals f of x equals 1 over 4 x squared minus 2. Let's just do the other one in green to show the contrast. That would be y equals f of x squared minus 2, just to show how the growth would be different. So it would do this, and then up to plus 1, 2, 3. So it would do that. And then it would do plus 1, 2, 3, 4, 5. My next point would be right there, and it'd be right there. So that would be, this green would be the original parabola, just moved down to with that k value, right? The k value moved it down twice. But that factor up front, that 1 over 4, divided all my parabola values by 4 before we even moved it up or down, right? Order of operations is saying that 1 over 4 does everything first. So it takes everything, takes every value, and divides it by 4, right? That's the idea. That's what it's doing. Perfect. All right, let's leave this video here. Went a little bit longer than I wanted to, but we are there.